So they give us the coordinates of point A, they give us the coordinates of point C, and they tell us that the length of segment BC, so there must be some other point here too, B, right? The length of segment BC is 13, and angle ABC is a 90-degree angle. So angle B is the right angle, right? So we can draw this thing, we can try to draw it somewhat correctly, but as we're going to see, it doesn't even really matter if we're too specific, because with a geometry drawing, all that really matters is the number information that's given to us in the drawing, numbers and symbols, right? We should never assume that they're drawn accurately into scale. It's almost never going to be the case. We'll start off trying to be somewhat accurate though. So we end up with, we try to graph these or plot these points. Let's see, we get point A is at -7.5, so that's, if this is the XY plane, that's just going to be back about 7 and up about 5. So like right there-ish. That sound good? There's point A, coordinates -7.5. Point C is at 4, -6, so I'm going to go over 4 and down 6. So, something like that, right? Okay, where's B? Who knows? It could be in lots of places. Angle B is a right angle. So there's maybe a temptation to draw it like this. We could maybe draw it where it goes up like that and over like that, and I form a right angle. But we don't know that. That's one possibility. But it could also be, it could even be something like this, like maybe it goes like that. And that's a right angle, right? We don't know. How do we know? We don't know the coordinates of B, do we? Right? So we don't really know. So we'll just draw one that's just kind of random, because we don't know what it really looks like. So we'll just, how about if we just draw one that's like, I don't know, like, maybe not quite like that. We can go further away. How about if we draw one kind of like this? We'll just draw this one because it looks nice. But we don't know the coordinates of B, do we? Agreed? Agreed. Okay. Now, what does this make, though, if I connect all the... It's a right triangle, doesn't it? Okay, well, we do know, they tell us that the length of segment BC is 13. Okay, that is important maybe, though, right? So the length of segment BC is 13. We're trying to find the length of segment AB, so what could we call that maybe? X, just to make things simple. So we're trying to solve for X, right? Do we know the length of segment AC? We don't know it directly, but we could sure find it, couldn't we? Because we know the coordinates of A and C. And so how would we find the length of that segment then if we know the coordinates of A and C? Plug it into what? Okay, okay, kind of. I mean, into the distance formula, which is our Pythagorean distance formula, right? So we know the coordinates of A, we know the coordinates of C. What is delta X going to be in this case, if we're going from A to C? It's going to be, what are the two X values? -7 and 4. Which one's bigger? 4. So we always take the bigger one minus the lesser one, right? So we're going to get 4 minus negative, makes it a plus, 7. So we get 11. Okay, what about delta Y? What are my two Y values? 5 and -6, which is bigger? 5. So 5 minus a negative makes a plus. 6 equals 11. Okay, so then we can use the distance formula. Just tells us, right, that D equals the square root of delta X squared plus delta Y squared. That's our easy formula, right? So for AC, we could just plug in what we know. AC is going to equal the square root then of what squared? What's it? Delta X? 11, yeah. So 11 squared plus delta Y is? 11 squared. Okay, so that's just the square root of 121 plus 121, which is the square root of what, 242? Okay, so where does that go on our triangle then? Yeah, that's the hypotenuse, isn't it? Right? Okay, so now what's our Pythagorean relationship? Because we have a right triangle, don't we? Remember, we always just kind of draw, when we want to represent the Pythagorean theorem, we usually just draw something like this, right? What do we call the legs of the triangle, typically, in the Pythagorean theorem?
A and B.
A and B. And the hypotenuse we call C. And what's the relationship? Yeah, A squared plus B squared equals C squared. That's the Pythagorean theorem, right? Okay, so for us over here, we don't have A's and B's and C's. What do we have?
A, B, and X.
So we got X and 13 are the legs, and the hypotenuse is the square root of 242. How do I know this is the hypotenuse, by the way, again? How do I always identify the hypotenuse in a right triangle?
It's not connected to a 90 degree.
Okay, right. It's not connected to 90 degrees. In other words, it's opposite the right angle, isn't it? It's always the angle that's opposite the right, or the side that's opposite the right angle. So then we would have A squared plus B squared equals C squared, where instead we get X and 13 in the square root of 242, right? So then doesn't that just look like X squared plus, that's my A squared, right? Plus, instead of B, I've got 13 squared, and instead of C, I've got this weird number, but that's okay, it's just a number. Square root of 242 squared. So what's 13 squared? Anybody know? 169. Now, yeah, this is a weird one. What's the square root of 242 squared?
242.
242. What's the square root of 91 squared?
91.
91. What's the square root of 37 squared?
37.
37. In other words, when I square a square root, they just cancel out, right? Okay, so these go away, and I just get 242. What am I trying to do again? Aren't I just trying to find X?
Yep.
Right? That's the answer to this. That's the length of side AB, right? So I'm just trying to solve for X, and that's my answer. Now, we've got this quadratic equation, but this one's a little bit easier than the one we looked at yesterday. The one we looked at yesterday was a little more challenging because we had X squareds and X's in the equation. There are no X's this time, are there? All we have are X squareds. So can you think of maybe an easier strategy how we could solve for X? What do you think? Could we get that X by itself? We always said from the beginning of the year, if I can point to a single X, I can isolate it, right? Well, I can't. I can point to a single X here. So how do I get that X by itself? What's the first step?
Subtract 169.
Everybody agree? First I gotta subtract 169. Because really all we're doing is just, remember, we're just working backwards through order of operations, right, when we want to solve something. So we're going in that direction. So first we're going to undo addition. So we'll subtract 169 from both sides, cancels, and I get X squared equals 73. Okay? Now what? So I check that one off, there's no multiplication, but exponents. How do I undo a square? Square root, right, I square root both sides. So if I square root both sides, the square root of X squared equals the square root of 73, right? Okay, now be careful with this. So we get X equals the square root of 73. And that's a fine answer because all they're asking for here is a decimal, right? So all I have to do is put the square root of 73 in a calculator and round the decimal. I don't have to do any simplifying, right? Okay, but is that my only answer? This is the part that's a little bit tricky. You might remember this from last year. Let's look at it just for a second. Let's look at a simpler example. What if I had, for example, X squared equals 4? Same kind of a thing, right? I'm going to square root both sides, and I get the answer X equals 2. Is there another answer though? What is it? Negative 2, right? Because 2 squared is 4, right? But so is negative 2. Remember this? So we have to remember that whenever we're solving an equation and we take a square root of both sides, you can't forget that plus or minus. So we need one here also, right? So I really get two answers. My two answers are either x equals the square, what happened there? Either x equals the square root of 73 or x equals minus the square root of 73. Okay, but those are the mathematical answers. But this is a geometry problem, right? So this is kind of like what we looked at yesterday a little bit too. We got two answers. Do they both make sense in a triangle? Can the side length of a triangle be negative? No, it can't be, right? That's impossible. A length is always positive, or zero, I guess, but it can't be negative. And so we could take this mathematical answer and cross it out. Does it make sense in terms of the problem that we're doing, right? So we're only taking the positive one. So our answer is just the square root of 73 rounded to however many places they ask for. So 2 places to the 100th, right? Make sense?
Yep.
That's it. Okay. Have at it.